So basically, as in this chapter, we are going to separate different mixtures. So, and I told you that how can we determine the purity of a substance? So remember, if you are going to find out the purity of a substance, so you have three ways. Remember, you have three ways to find to find to find purity of a substance. To find purity of a substance, you have three ways. Number one, boiling point. Then we have melting point, and then we have chromatography. I would be telling you what is chromatography. But remember, these are three methods by which we can tell the purity of a substance. So boiling point is specific for liquids. If you are going to tell the purity of liquid, okay? For liquids, or this is for solid. Okay. Now, the next thing is that I told you that this is a glass of water, right? And this is water. This is water, just like this. Okay. H2O. This is H2O. And I'm saying that this is pure water. This is pure water. So obviously, if this is pure, so its boiling point should be 100 degrees Celsius. Its boiling point should be 100 degrees Celsius. Exactly. If I'm going to add any impurity, if I'm going to add any impurities, such as sodium chloride, obviously this is an impurity. Anything that is an extra, let's suppose the formula for water is H2O. So it should be H2O, not other than any species like it may have, including sodium chloride, glucose, sugar. You have like different ions. Anything. It must not have anything. Okay. So if the formula is H2O, it's mean that this is pure. Okay. So I'm telling you that I'm going to add sodium chloride as an impurity. Now the question is, can you tell me boiling point will increase, will decrease, or it remains the same? Can you tell me?
Increase.
Increases.
Boiling point will increase. Boiling point will increase, remember. So if you are going to add impurity, adding impurity will increase the boiling point. Remember. So after addition, when you are going to boil that liquid, that water, so you will see its boiling point will be 102 degrees Celsius, 105 degrees Celsius. It should be greater than 100. This is the main point. Okay. And what if, let's suppose this is a piece of iron. Let's suppose this is a piece of iron like this.
Sir, we can't hear you.
I'm going to add impurity in this solid. Let's suppose addition of impurity in this. I'm going to add impurity. Adding impurity, okay, impurity in this solid. So remember, as I told you, addition of impurity will increase the boiling point. So for solids, addition of impurity will decrease the melting point. Remember, adding impurity decreases melting a solid. You must know this, okay? And then is
Sir, your voice
sand
is cutting.
Sir, we can.
what? Sand from water. We have to separate this sand from water. So what can I do basically? I'm supposed to take this retort stand just like this. This is a retort stand, and this is a beaker, and this is a beaker. Okay, this is a beaker just like this. Okay, uh, like this. In this beaker, we have a funnel like this, like this. And then we have another beaker. We have another container. Okay, we have another container in which just see this, in which I have okay, sand and water. This mixture, then I'm going to have a filter paper on it just like this. This is a filter paper. Okay, this is a filter paper in the, you can say, funnel. Now I am supposed to label it. This is funnel, beaker, lagging. I'm lagging.
Yeah.
Yet here.
Okay.
Yeah.
This is filter paper. This is a filter paper. Okay. And this is stand. This is a stand. Okay. Now, when we put this mixture onto the filter paper, so only the water will pass through the filter paper. The filter paper can only allow the liquid particles, the water particles, not the sand particles. Remember, why? Why? Because the size of the sand particle is larger. Because the size of the sand particle is larger, basically. So you can see this is, filtrate. This is a filtrate, and you will see some particles on the filter paper. This is the sand particle, which is called a residue, basically. So if I'm supposed to define that what is residue, so
Which residue?
residue, exactly, residue means that insoluble substance, insoluble particles left behind on the filter paper. And what is, you can say, filtrate? Filtrate means soluble particles which have passed through the filter paper. Okay. So this is all about filtration. This process is known as filtration. So when we do filtration, when we are going to separate insoluble particle from the solution. Okay. So what is filtration? What is filtration basically? When we are going to separation of insoluble particle from solution. This is all about filtration. Okay. How the filter paper works? How the filter paper works? Mechanism of filter paper, basically. Like mechanism of paper, that is what meant 41 filter paper. This is a special type of filter paper, okay, which is very fine, which is which does very fine filtration. Like this filter paper will never allow, the smallest particle, smallest insoluble particle to pass through this. Only he will be allowing the liquid particles which can pass through the filter paper. That's it. So means that this gives very, you can, yes, you're saying something, Ayat? No, Abdul Rafi, who was there? Any question?
No, sir, no.
Okay. So basically, let's suppose this is a filter paper like this.
Sir, what's written down the filter paper in the purple color?
Sorry,
What's written in the purple color? Like something written. What is it?
this,
Yeah,
this,
yeah.
this is Wattman 41 filter paper. Wattman. This is double T.
Oh, okay.
Wattman 41 filter paper. Okay. This is sand particle. This is sand particle. This is water particle. So filter paper will not allowed to pass through. Why? Not allowed to pass through. Why? Due to larger size. As you can see, these pores are very small. Pores are very small. They can only allow those particles having smaller size. So you can say these are the water particles. These are the water particles that easily pass through this is very simple. Okay, so this is the mechanism of filter paper, that how the filter paper works. Depends on the pore size of the filter paper. If you are going to take a low quality filter paper, so there would be a larger pore size, so it will not be blocking any like you can say the few particles of the sand will be passing through that filter paper due to the larger pore size. But if you're going to take a special, like you can say, accurate filter paper having the very small pore size, so the filter paper will not be allowing that the smallest particle which can pass through the filter paper. So yes, we know that it takes so much time to pass through, because the size is very small, so the particles cannot pass through very easily, even the liquid particles, due to the very small pore size. So very slow process, but very accurate process. Remember, okay? Very slow process, but very accurate process. So when you will see the filtrate, as you can see the filtrate, when you will see the filtrate like this, the solution which has passed through the filter paper, it's very clear. It's very clear. There is no any sand particle in that solution. So this is very accurate liquid. It shows that the filter paper is going to give you the very good separation. Even the smallest particle you will not see in that solution. Okay, so this is a good separation basically. And then what if I'm telling you that I have to separate soluble particles from the solution? So what would you say? Soluble particles, soluble particles from the solution? Yes. What do you think? What we are supposed to do?
Crystallization.
Sorry?
Boiling.
Boiling. Okay. Or she was saying crystallization. Any other thing that you are thinking that it should be? Yes. We can do
Distillation.
distillation, crystallization, evaporation. So we have the three procedures. Number one, we can do evaporation. We can do evaporation. We can do crystallization. We can do simple distillation. Okay, these are the three processes that we can use if we are going to separate the soluble particles from the solution. So to be specific, we are going to separate the sand from the seawater. Okay, sand from seawater. Yes. Okay, so the first process that we are going to have, evaporation. Evaporation. Okay, so let's suppose this is you can say any dish, China dish, let's suppose, in which I have some seawater. This is a seawater, like you may consider right now. This is a seawater. Okay, and I'm going to heat this mixture of soluble salt and water. Okay, so once you have started to provide the heat to this mixture, that is the seawater, so you will see water will be starting to evaporate like this. So after some time, you will see that as you can see that after, you can say, after after 10 to 15 minutes, after 10 to 15 minutes, you will see that we have some insoluble particles which are sticked to this surface. So we would see it after the evaporation for 10 to 15 minutes. So basically, this is your salt. This is your salt, and water is evaporated into environment. So water is lost. water is lost. You cannot have water again. It's lost. It's a disadvantage of this process, that if you are going to separate one thing, so you are going to lose another substance. So this is disadvantage of this technique. So what should I do that I may have, like, I can separate the salt but without the loss of water? Can you tell me what we are supposed to do that we can separate easily? We can separate easily the salt without the loss of water molecule. Can you tell me anything? Yes. Shaban, Rija, Reni, Huria. Yes,
Uh,
can you tell me?
we actually like cool the water down so that we obtain a liquid form.
Sorry,
Distillation.
We
distillation.
we cool the water vapors so that we get a liquid.
Okay. So she was saying distillation. Okay.
Yes, sir.
So basically condensation.
Exactly. Exactly. We can do distillation process. But remember, the salt that we are going to obtain as a result of this evaporation is impure salt. Is impure salt. And remember, the salt that we are going to obtain from this technique is a powdered salt. Is a powdered salt. Remember, because you have provided strong heating so that the water may evaporate in a faster manner, and I may have the salt. I may have the complete separation. So, when we provide strong heating to the salt, the crystal breaks down. The crystal breaks down. So after breaking down the crystal, you will see the fine powder of the salt. Like let's suppose I'm saying that this is the salt that is obtained from evaporation. Just focus on this. This is very important topic. Like let's suppose this is the salt that we have separated as a result of evaporation. And I'm saying that this is impure salt. I'm saying that this is impure salt. Now, some like let's suppose Adan asks, sir, where is the impurity? So where is impurity that you're saying that this is impure salt? So remember, this is your impurity. This is your impurity. Just like this. Yes, 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 yes. So this is your impurity. The blue one is impurity. The blue one is impurity. So I'm supposed to write this is impurity. Okay. And these are the salt particles. These are the salt particles. These are the salt particles. Now Aryan is saying, sir, just separate impurity. Just separate impurity. But how? But how? The size is very small. How can I separate? Let's suppose I'm going to give you talcum powder. I'm going to give you a talcum powder, prickly heat powder, let's suppose. Okay. And also I'm going to mix some sort of any white substance like white color into that, you can say, talcum powder. So the talcum powder is pure. If you are going to add impurity in the form of white color, like powdered color, so obviously your talcum powder would impure after the addition of that impurity. Now I'm saying, can you separate the impurity that you have just added into it? You will say no. I ask why. You will say they are very small particles. How can I separate? So the same, so the same goes here. So the same goes here. Since the size of the particle is very small, so we cannot separate the impurity. That's why, as a result of evaporation, the salt that we are going to obtain, that is impure salt. Okay, that is impure salt. So we have some impurities that can easily be passed through, but when we would be having the large size of the salt. Simple, simple. This is very easy. Okay. So the drawback for this technique is that, okay, the salt that we are going to obtain as a result of evaporation is impure salt. Is impure salt. Uh, yes, I'm supposed to write. Okay. So I was saying that we obtain insoluble salt. Oh, sorry, impure salt. Okay, impure salt basically. So, but also we cannot separate impurity due to small size. Why I'm saying this? In this, both, in this, both, that is the salt and impurity, both sizes are very small. So it's difficult to separate these. And also, not only this, we are going to lose, water. We are going to lose water. So this is a drawback of this technique. So I can say disadvantage of this technique is that we are going to lose solvent. We are going to lose solvent. That is water. The solvent is in this case, that is water. Okay. Now I'm saying that I want to obtain a pure salt. I want to obtain a pure salt. So which technique am I supposed to use to obtain pure salt? Can you tell me?
Distillation.
Crystallization. We can use crystallization. Yes, we know that in crystallization as well, we are going to lose some water. We are going to lose some water, same as evaporation. Same as evaporation. But remember, in crystallization, we would be obtaining the pure salt. Remember, we would be obtaining the pure salt. So you can say that the very first procedure is to use evaporation. If just you have to do a separation, if the pure substance is not required, so you can do evaporation. This is a cheap technique. But if you are going to have any, like you can say, the requirement is to obtain a pure salt, so then you are supposed to use crystallization technique. Okay. And then if you want to have water like a solvent, and also if you want to separate the pure substance, so then the third one is you can say a simple distillation. Okay, so the primary procedure was evaporation. As a result of evaporation, we have separated the salt from the solution. So the salt that we have obtained is an impure salt, but we know the impurity, but unfortunately we are not going to separate this impurity due to the smaller size. Okay, so that's why we are saying that you can say to obtain a pure salt, so we are supposed to use crystallization technique. The whole process is the same, like we would be having the same solution like the salt solution, like a seawater. But remember, in crystallization we must have a saturated solution. Can you tell me what is saturated solution? Yes, can you tell me what is saturated solution? Anyone? Yes, saturated solution. Yes, Hamna, can you tell me? Yes, Hamna. Hamna, where are you? Hamna. Hamna, are you here?
Sir, a saturated solution is when no more solute can be dissolved at a certain temperature.
क्या बात है यार, क्या बात है, क्या बात है, good. So we cannot add more amount of solute. So remember, before doing crystallization, you must have a brine solution. I'm using the term brine. You know, brine is a saturated solution of sodium chloride. Brine is a saturated solution of sodium chloride. So inshallah we would be discussing in the next class crystallization. Okay.